composite functions. Now I'm going to presume that you know a bit about functions already, so I'm not going to talk about those. Go and watch another video if you need to. But composite functions are a merging of two or more functions into a single one. Now before I kind of do that bit, I'm going to start with this notation here. So I've got f of x equals 3x minus 2. There's my function, f of x. And g of x is x squared. If this question here is saying calculate g of f of x, or in this case g of f of 4, and that's how we say it, g of f of 4. So you do start from the left to the right, and it means basically working out one function, getting the answer, and then putting that answer into the other function to see another answer. It's effectively what we're doing here. We're going g of f of 4, again, apologies about my writing there. We're putting f of 4, whatever the answer to that is, we're going to put into the function g. So let's move over here a little bit, which means I need to know what f of 4 is. You can do one and then do the other. Now f of 4 will be 3 lots of 4 take away 2. 3 lots of 4 is 12, take away 2 is 10, and then I do put that answer into the next function out. So you start from the inside and work out. So we started with the f, got the answer, put that into the g. And that will be g of x, obviously, is x squared. So this will be 10 squared, which is 100. And we could do that for individual ones, right? But instead of doing two calculations, we could find the algebraic result of the two calculations. And that would give us like a new function, which means we'd only need to do the calculation once. It's the algebraic result of putting the two together. So g of f of x will be g of f of x, like that. So we're going to put in the function, the actual function of f of x, which is 3x take away 2. We're going to put that into g. Now g is x squared. So this will be that algebraic expression, 3x minus 2 squared, because that's what the function of g is. It's, you square whatever's in the bracket there. I would then square that. I'd have 3x times by 3x obviously makes 9x squared. We'd then have a 6x. We'd have another 6x, and then I'd have positive 4 from the negative 2 times by itself. So this is 9x squared take away 12x plus 4. That is what g of f of x is. That's the composite function of g of f of x. If we put the number, let's go right back to this. If I put 4 into this, I should get the answer of 100. All right, I could put any number into it, and then it would work out g of f of that number. Another example. Look, I've got that under there. Let's just wipe that away. I forgot that I did that. Let's get that. Much neater, isn't it? Look at that. Yeah, g of f of x. Let's go back to my pen and do another example. So calculate f of g of 3. So again, you start from the center there if you're just working out one specific value. And I would do g of 3, which is 3 squared, which is 9. And then I'll put that into the next function out, which is f. So it'll be f of 9. And this is f of x, so 3x minus 2. So 3 lots of 9 take away 2, which is 27 take away 2, which is 25. But again, I could do it algebraically. I could work out what f of g of x is. F of g of x. Remember, it's putting this inside function, this g of x, inside the function of f. I'm using square brackets there to differentiate it, I suppose, from those rounded brackets. So f of g of x will be, let's put in, there's f of, well, g of x is x squared, so it'll be that, f of x squared. Now, f is obviously 3 lots of x, so that will be, we're putting our function into it. Remember, our function's x squared. We're putting that into there. 3 lots of, what's in the bracket, take away 2, which is quite easy, really, isn't it? That is 3 x squared take away 2. That is what f of g of x is. You put one function into the other function, you do the algebra, and simplify it, see what you get. So if I put the number 3 into this expression here, I'd have 3 lots of 3 squared, so that would be 3 lots of 9, which is 27, take away 2, which is 25. Yeah. There we go, composite function. 2 more functions then, or slides. First one I've left the same, f of x is 3x minus 2. The second one is g of x equals 5x, so I've redefined g of x up here. So these are the other sort of questions that you might get that are along the same kind of lines. Solve f of x equals g of x. Well, it literally wants me to go 3 of x take away 2 equals 5x. It means quite literally just solve it. Obviously we've got x on both sides, so I'm going to take away 3x from both sides. Oops, that should be an x. And so we'll have negative 2 equals 2x. I'm then going to divide it by 2. I can find that that is going to happen when x is equal to negative 1. So I've solved it. You know, it just means just put in these expressions into there and then see what you get. Should we change the colour so it's not going to be quite so, closed up so you can see which one's which. Right, f of x plus solve. So we're trying to find the value of x again, where f of x plus g of x equals 14. I'm going to do that over here. Let's just put a little blue line down. So f of x equals 3x take away 2. It's asking me to add that to g of x and find out when the answer is 14. Well, I'm going to simplify this. The 3x and the 5x makes 8x. Take away 2 equals 14. Obviously, we're going to add 2 to both sides this time. So 8x equals 16. Divide it by the 8. And x is equal to 2. So f of x plus g of x will equal 14 when x is 2. Straightforward solving, really. What about when f of x, g of x equals 105? This means multiplied together. Let's get a new colour. What new funky colour have we got? We could go green. So we know, first of all, let's put this in a bracket, I think. 3x take away 2 is f of x. And g of x equals 5x. We want that to equal 105. And then just, as I say, crunch the algebra, do the work. 3x times 5x is 15x squared. Negative 2 times 5x is negative 10x. That equals 105. I need to take 105 away from both sides. So we'll have 15x squared, take away 10x, take away 105 equals 0. And I've done that because this is a quadratic expression. I need to try and then solve this. So we're going to have 2 possible answers for this. This makes it a little bit easier. All of these numbers divide by 5. So we'll have 3x squared, take away 2x, take away 21 equals 0. And then you would use whatever method you've got for solving those to obviously to solve it. My one is that I like to multiply together the outside numbers. So that will be negative 63. I need my factor pairs. And this pair of numbers needs to multiply together to make 63, add together to make negative 2. Which for me is going to be 9 sevens, isn't it? 9 times 7. I need negative 2, so it's going to be the 9 that's negative. Now, this is how I tackle these. When a, the coefficient of x squared, so a is greater than 1, I put them both in a bracket. In this case, with 3x, take away 9. 3x plus the 7, because that was positive. And then you see if you can simplify. So this bracket here, both the numbers divide by 3, so I'm going to change that for x, take away 3 in that one, 3x plus 7 equals 0. And then my 2 roots then are going to be x equals positive 3 and x equals negative 7 divided by 3. So there are my 2 possible values that will make this expression equal 105. Right? Tricky one. We got one more. Okay, so I'll get rid of some of that writing. Sorry, let's just rub some of that out. Get rid of a bit more, so we got a bit of space. This time, it's asking me to write down an expression for for when f, the function f has 4x plus 2 inserted into it. Okay, so let's go for that. Let's go back to my pen. What colour are we on? Go back to red, shall we? So what's asking me to do is just insert that into the function, 4x plus 2. So that will be, my function f of x is 3x minus 2, so it'll be 3 lots of whatever's in that bracket. So the 4x, what they say, plus 2. And then we're putting minus 2 on the end, because that's the original function. 3 lots of the bracket minus 2. 3 lots of 4x is 12x. 3 lots of 2 is 6. Take away the 2, the answer is going to be 12x plus 4. Okay, hope that makes some sense. From the textbook then, let's get rid of all my scrawly writing. From textbook, page 48, 3C. Now these references, once again, reference this book, the AQA Level 2 certain. It makes it sound like I'm paid by these people. I'm really not. It just happens to be the textbook that I use in my school. Hodder Education if you want to do that. But any questions, I'm sure it'll be great. Off you go. And once again, enjoy. I'm off for a mince pie in the middle of September.